Hello everyone, in this video I'll explain the algebraic method for finding limits. So I'll only discuss the case when the independent variable is approaching to a real number. So I'll show you different tricks that you can use to solve problems in that case. So first whenever we start a limit problem, the first step we do is we plug in the number. So here we have limit x approaching to 2. So let's just plug in the number 2 and see what happens. So when we plug in the number 2 here, we get 12 minus 10 minus 2. So 12 minus 12, 0 on the top, and 2 minus 2, 0 on the bottom. So this is an indeterminate form. So it means we need to do some more work. So when you have indeterminate form, so in order to do more work, what we can do here is we have quadratic on the numerator and we have a linear factor in the denominator. So the way we approach this problem is we factorize the top and see if the troublemaker factor, which is x minus 2 here, so if that cancels out. So when I factorize the numerator, I get 3x plus 1 times x minus 2. So this is equivalent to 3x squared minus 5x minus 2. And in the denominator, we have x minus 2. So in this case, if you're wondering, where did I get the factors from? So just a quick overview. So in order to factorize ax squared plus bx plus c, so a quadratic expression. So what we do, in this case, we have 3x squared minus 5x minus 2. So we try to find two magic numbers such that the product is a times c. So in this case, the product should be 3 times minus 2, which is minus 6. And the sum should be equal to the middle term, which is b. So in this case, the sum should be negative 5. So if you think about the two numbers for which the product is 6, sum is negative 5. So those two numbers would be negative 6 and 1. So once we get the numbers, we split the middle term, right, using these two numbers. So now I'm going to split my middle term. So I'm going to rewrite my quadratic expression as 3x squared minus 6x plus x minus 2. And next step, we're gonna make the grouping and we're gonna take out any common terms from the grouping. So in first grouping, we have 3x common factor. Inside, you're left with x minus 2. In the second grouping, you just have one common factor and you get x minus 2. So now again, we have two terms now. In the first term and in the second term, you have x minus 2 as a common factor. So bring the common factor out. Inside, you're left with 3x and plus 1. So this is how we factorize it. So now we notice that when we factorize it, this was the troublemaker factor which got cancelled out. So this is the one which was making 0 on the top and 0 on the bottom. And we are left with limit x approaching to 2, 3x plus 1. So let's try to reevaluate our limit again and see what we get. So we get 7 in the end. So that is our answer for the limit. So the trick is whenever you have quadratic over a linear fraction or linear factor, so make sure you try the factoring first and see if that works for you. So let's take a look at the next example. So in next one, again, the first step is we start plugging in the value. So on the top we get 1 minus 1, which is 0. On the bottom we get 0. So again we have indeterminate form. So it means we need to do some algebraic manipulation before we can actually evaluate the limit. So whenever you have the square root sign in individual term on the top or on the bottom. So the trick is we do the conjugate multiplication. So we multiply and divide by the conjugate of that factor. So in this case, we're going to multiply by the conjugate of numerator and divide by the conjugate of numerator. So conjugate is you just change the sign of the expression. We notice that on the top we have this form x minus like a minus b times a plus b. So which is difference of squares. So a minus b times a plus b is difference of squares. So we're going to use this and we get square root of x squared minus 1 over x plus 1 times square root of x plus 1. And in the next step, square root of x squared is just x. So x minus 1 over x minus 1 square root of x plus 1. So sorry, here we had x minus 1. It's just a typo. We notice that we get rid of our troublemaker factor, which was x minus 1. So this was a factor that was making 0 on the top and 0 on the bottom. So now we got rid of this factor. And in the next step, we just have limit x approaching to 1 over square root of x plus 1. So now is the good time to plug in the value again. And from here we get, so 1 over 1 plus 1, which is just 1 over 2. So trick is whenever you have square root sign in the individual term in the numerator or the denominator, so multiply and divide by conjugate. So that will help you to solve the problem. Next, we have the example in which we have subtraction of some fractions involved and also multiplication. Again, the first step is you plug in the value. So we get 1 over 5. So when we put x equal to 0, we get 1 over 5 minus 1 over 5, which is 0. And 1 over x is also 0 in the denominator. So you get 0 over 0 form again. So this is again our indeterminate form. And now we're going to try to do some algebraic manipulation. So what we're going to do is we're going to subtract the fractions and try to combine them. So in order to combine the fractions, we need to use the common denominator. So first step is find the common denominator to add or subtract the fractions. So in this case, the common denominator will be 5 times 5 plus x. So it means 5 times 5 plus x, we need to make the common denominator. So here we divided by 5, so we have to multiply by 5 so that we keep the equivalent fraction. Similarly, here we divided by 5 plus x, so we need to multiply by 5 plus x as well to make the equivalent fractions. And then we get limit x approaches to 0. So we got 5 plus x. And on top we get 5 minus 5 plus x. And outside we have 1 over x. So in the next step, we see that we get limit x approaching to 0. So when we open the bracket here, so we get negative 5 and again negative x, 5 times 5 plus x, 1 over x. And here we notice that our factors, our terms 5 and negative 5 get cancelled out. And we get limit x approaching to 0. So we have negative 1 negative x, 5 plus x times 1 over x. I was thinking ahead. So we get negative 1 now because x and x cancel each other. So limit x approaching to 0, negative 1 over 5 times 5 plus x. So after simplification, we got this. So let's try to plug in the values now and see what we get. So we get negative 1 over 5, 5 plus 0, negative 1 over 25. So this is the value of our limit of the given function. So the trick is, if you have one or more fractions and you have addition subtraction in between, so simplify by combining the fractions together. So I hope you enjoyed my all tricks, and thanks for watching this video. In the next video, I'll explain another case of algebraic method when the independent variable approaches to infinity or negative infinity instead of a real number. So please do watch that video as well.